Hi, my name is Anupam and I work as language architect in Broadcom's switching architecture group. Today I'm going to talk about some advanced constructs in NPL language. NPL, which stands for Network Programming Language, has many basic constructs to express parser, editor, match actions. However, there are cases when target vendor has some hardware efficiencies, and these hardware efficiencies need to be expressed by the language. So in NPL we have multiple advanced constructs to express these hardware efficiencies. Although these are complex operations, but from language design point of view, we have made sure that these are easy to understand and express. So the first item that we are going to talk about is multiple lookup logical table. NPL allows end user to specify logical tables. A logical table has keys, field, and then other properties. In order to construct the key, an end user can specify a key construct block. Similarly, for field assigning or field usage, end customer can specify a field assign block, just like over here. In case of some target architecture, physically it may be possible to do multiple lookup in one physical memory. In order to express this hardware efficiency, we have multiple lookup logical table feature in NPL language. So I'll draw a block diagram over here and correlate with the code on this side. Here is one logical table, and in NPL, user specifies a key construct block. Corresponding to this key construct block, there is a fields assign. Block. These two things are marked in blue on this side. Now, when an end user wants to specify multiple lookups, he has to specify another key construct block. And correspondingly, there should be a field assign block. The way to demarcate between these two key construct and field assign is by use of metadata. For first lookup, end user should use lookup 0, and for the second one, NPL writer should use lookup 1. As you can see on this side of the picture where you have code, lookup 0 is being used to pick DA and construct a MAC address as a key to this logical table. Similarly, under lookup 0, we are using fields from the logical table and assigning it to destination of the buses. When end user wants to specify second lookup, he uses underscore lookup 1, in which case SA is being assigned to MAC address as a key, and similarly the fields of logical table are being assigned to a different set of fields on the bus. So this is how NPL allows end user to express hardware efficiency, which was implemented in the physical memory by target vendor. Next, we are going to talk about reentrant parser tree. NPL allows user to specify different parser nodes and a parser tree to do a full packet parsing traversal. However, some protocols need the parser tree to break and thereafter do either a table lookup or do some type of processing and thereafter the parsing should start. For example, MPLS, VPLS are some of these protocols. In such cases, there could be some either chip properties or any custom properties which are required for parser tree to move forward. So on this side here is an example, and I'll draw a diagram and correlate with that. Let's say there is a parser stage 0. Thereafter, a user would like to do a table lookup and continue further with parser stage 1. So over here, a user will specify parse break construct to indicate that the flow has been broken from parsing, and once a lookup has happened, thereafter a user will specify parse continue. As you can see on this side, in program we have parse begin, which is where parsing has started. Thereafter this parse break kicks in over here under a condition. A table lookup is performed, and then thereafter we start parse continue from the next parsing node, which happens to be again an MPLS. So this is how NPL allows end user to specify some processing or a logical table lookup during the parser tree traversal. Next item that we are going to talk about is strength resolution. NPL allows parallelism. So NPL allows multiple logical tables to be specified in parallel. There are certain conditions when you look up tables in parallel. All of them may like to assign same network object, let's say virtual port. In that case, there is a need to do a resolution among those same objects. So I'll draw it and explain the concept with a picture. Let's say there are three logical tables A, B, and C which are looked up in parallel, and there is a flex bus which is going simultaneously. All of these are going to assign, let's say, a virtual port. Now only one of these virtual ports can possibly be assigned on the bus. In that case, NPL allows user to specify strength resolution, which is essentially a numerical comparison locally next to all the logical tables, by which we can determine which logical table's virtual port will traverse further on the bus. Without this concept, normally user would have to take 3 different virtual ports to the next stage and resolve it over there, which is less hardware efficient. So to add to it further, we have a concept where we can have old virtual port on the bus, and this new virtual port and the old virtual port can also be resolved in this strength resolution block to figure out which of the virtual port wins going forward. So there are a few more advanced constructs we have in NPL. One is variable size header manipulation. With advancement in instrumentation, different switching nodes have need to attach different size metadata depending on at what point in network the switching nodes are deployed. So NPL lets NPL writer to specify different size of metadata and attach them to the packet. A user can also delete different size metadata from the packet. Another cool concept that we have in NPL is target vendor IP protection type of constructs, where a target vendor can specify a hardware accelerator or maybe an IP that they want to hide from end user. In this case, a target vendor can only specify the interface. They need not specify the internal. And NPL writer, when he is using this accelerator in the program, is going to instantiate this particular special function using just the interface. So 3 constructs which are there in target vendor category. One is externs, which are basic building blocks which can be called multiple times in the program. Second is special function, which are for hardware accelerator. And third is dynamic table, which is for runtime programmability. So that's all I have in terms of NPL Advanced Constructs. Thank you very much. Thanks for watching.